Well wishes, friends. Today we are going to start a new topic, that is motion in one dimension. Okay. Before going into the detail of motion in one dimension, there are some basic definitions and rules which we have to understand first. Okay. This is the entry gate to physics. Now, what are those important definitions or those important things which we have to learn? To analyze motion, these are the tools to analyze motion. So first of all, let us take a look. What exactly is the meaning of motion? The definition reads like this. Motion. What is motion? When a body changes its position in time, then we call it as motion. And when the body does not change its position in time, then we say that the body is at rest. Now, what is meaning of this? So, in order that the motion should take place, you have to take care of two things. Number one, the position of body must change. That is number one. And number two, to know whether the position of body is changing or not, you have to give it some time. Okay, that means you give time to some objects. This could be 5 seconds or 5 hours or anything, any given time, and in that time you notice whether the position gets changed or not. If the position gets changed, then the body is said to be in motion, and if the position does not change, you can say that during that much time the body was at rest. Okay, so the change of position is important, and the change of time is also the change of position in sufficient time. Both are important ones. Suppose if you don't give time to a body to do motion, and then you say the body is at rest, oh, the body is obviously going to be at rest because you have not given it proper time to do the motion. Okay, so consider both these terms as important to decide whether the body is at motion or at rest: position as well as time. Now, what is the next thing? After rest and motion, the third thing we have to understand is this: particle. What is meant by a particle? The definition of particle, the explanation of particle is very much similar to the concept of point in mathematics. What is a point? In mathematics, the point is defined as a body that is having no length, no width, no height. Okay? This seems to be an impossible kind of something, that there is an object, but the object has got zero length, zero width, and zero height. But this is basically a concept. Okay, there is actually no such body in the universe which follows this equation strictly, but still, for the sake of definition, and why not? Not only for the sake of definition, for understanding the concept, we need the concept to understand the concept of motion. We need the concepts of particle as well as point object. What is the meaning of this? That length and width and height are all zero. It means simply that we will not be considering the length, width, and height of the object. Suppose if I am doing the motion, okay, then definitely I am going to have my length, width, and height. I am not going to lose it during motion. But the meaning over here is all of them equals to zero. It means that whatever is the length of the body, whatever is the width of the body, whatever is the height of the body, it is not important for us. That is the meaning of this first statement: length equals to width equals to height equals to zero. Okay, we are not considering it. But when it comes to physics, the basic thing is particle. And what is a particle? Particle is again something which is having length equal to width equal to height equals to zero, but the mass of that is not equal to zero. Means you have to neglect the length, width, and height, but you cannot neglect the mass of the particle. Okay. Now, in this concept of particle, there is one more thing to be understood, that sometimes a body can be a particle and sometimes the body may not be a particle. This is some kind of controversial statement. Okay, paradox, what we call in English. But there are chances when something behaves like particle. Suppose you and me, we are living on this planet called Earth. Earth is a very huge body, and we have to consider its length, width, height, its radius, its surface, everything. So when we are living on the surface of Earth, the Earth cannot be taken to as the particle. But when you study the motion of the Earth around the sun, okay, then what you have to do? You have to consider it as a particle. Otherwise, you cannot apply the equations. You cannot study it properly. Okay. So the Earth, when it comes to us, it is a body, a huge body. But when it comes to the study of motion of Earth around the sun, then it cannot be considered as a body. It is then considered as a particle. One easy example I will give to tell you to differentiate that when a body is considered to be a particle and when it is not to be considered as a particle. Suppose if my size is say about 5.5 feet and I am moving by a distance of 10 feet. Okay. Now try to visualize everything between the starting point of my motion and the ending point of my motion. Okay. Now if you have visualized this, then do I appear to you like a small point or do I appear to you like a big body? Obviously, I appear to you like a big body. So I am not a particle. But now suppose my height is about say 2 meters and I am moving by a distance of 1 kilometer. Okay. Now again try to see my starting point, my ending point and my track, my path. If you see all the three things at once, okay, that means you have to visualize the distance of 1 kilometer as well as you have to visualize that I am moving on that distance of 1 kilometer. My height is 2 meter. Now, how do you see me? Do you see my length or width or height? No, you cannot. Now I will appear to you as a single point. So now you can consider me as a particle. Okay. Same way, suppose you are moving on your bike from covering a distance of say about 10 meters, then you are not a particle. But when you are going on your bike and covering a distance of 1 kilometer or 10 kilometer, then you are what? Then you are a particle. Okay. The next thing to understand is reference frame. Reference frame. Now this is new word, reference frame. What is a reference frame? See, reference frame is not a very complicated thing. In previous classes, in lower classes, you have studied the concept of number line that starts from 0. One side it is having positive numbers, other side it is having negative numbers. So that was what? That was a number line. Now later you studied graphs. Now the graph had two axes, one horizontal and one vertical. Okay. So that was having say x-axis, positive numbers one side, negative numbers on the opposite side. Similarly, y-axis was having positive numbers upwards, negative numbers downwards. So if you are using two axes, x and y, then you are doing two-dimension study. Okay. Now if you consider its horizontalness, its verticalness, and also something going in and out of the paper. Okay, x-axis is going left and right, y-axis is going up and down, and if you consider one more thing, that something is moving in and out of the paper, then that axis will be taken as z-axis. Clear? So the word that we see around us, is it all x-axis or only x and y-axis, or includes x, y and z, all the axis? It includes all the three. Okay, so we are living in a world which is expressed by three axes: x, y and z. Along with these three axes, if we also place an invisible clock, do you want to see an invisible clock? Okay, here it is. This is my hand and I'm wearing an invisible clock on it. Can you see that? No, you cannot see, because anyway it isn't going to be invisible. Okay, jokes apart. Now, what is this invisible clock? This invisible clock means that whenever we draw the diagrams, we are going to show x-axis, y-axis, z-axis, but we are never going to show that clock. We will show the time, but we will not show the clock. So, a combination of x-axis, y-axis, z-axis along with an invisible clock is said to be a reference frame. Clear? What is the need of reference frame? See, there is a need, a very strict need of reference frame. Suppose if you see any comet in the sky, you notice that it is doing some motion. Okay, now you can notice it only because it is changing its distance with nearby stars. Okay, suppose if all the stars, there are no stars nearby the moving comet, then you will not be able to notice whether it is doing the motion or not doing the motion. Okay, so sometimes, no, not sometimes, all the times, whether to know whether the body is at rest or in motion, we need a background. If the background is not available, then we put an imaginary background, and that imaginary background is going to be the reference frame. So there is a need of reference frame to study motion. What is next? Okay, starts with 3D motion, very easy to understand. See, if you draw a graph, you draw two coordinates, x coordinate and y coordinate. Now you are living in this world, which is a three-dimensional world. Okay, and it consists of three dimensions: x coordinate, y coordinate and z coordinate. That means its position on x-axis, its position from y-axis and its position from z-axis. If an object is moving in such a way that going from one place to another, one point to another, all the three coordinates change, then it is said to be three-dimensional motion. If it changes only two of its coordinates, either x and y, or x and z, or y and z, but any of these two changes while the third remains constant, then we say that the motion is two-dimensional. And if only one of the coordinates change, only one of the coordinates change, then we said that the motion is one-dimensional, just like used to happen in the number line. Okay, so these are 3D, 2D and 1D motions. Coming to next, what is next? Speed. No need to explain this. This is a very simple term, speed. Speed tells us that how fast or how slow the motion is taking place. And how to define it? It is a rate of motion that is defined as speed. What is speed? Rate of motion. Now, this word rate again needs a little explanation. What is rate now? Rate means dividing by time. Rate. The common word, the rate suggests that it is the price of something. Bhai iska kya rate hai, uska kya rate hai. It's not that rate. In physics, rate means dividing by time. If I divide x by time, what I am finding? I am finding the rate of change of x. If I am dividing, say, a by time, then what I am doing? I am finding the rate of a. If I am dividing me by time, what I am doing? I am finding the rate of me. So this is the meaning of the word rate. Whenever you see the rate, The mathematical exploitation of that will be that you have to divide it by time. Okay, so now coming back to the speed. So what is speed? It is a rate of motion that is known as speed. Okay, tells you how fast or how slow the objects are moving. What is next? Simple. Next one is acceleration. Okay, uh, you've understood, you have gone through this thing, acceleration. What is acceleration? It is the change in velocity. What is it? It is the change in velocity. But again, I would like to modify this a little bit. It is actually the rate of change of velocity. What is it? Rate of change of velocity. Again, the word rate comes. Now, a rate of change of velocity, it means you have to divide velocity or speed by time. So when you do this, what is this? Rate of change of velocity. And according to definition, what is rate of change of velocity? Rate of change of velocity is nothing but acceleration. Now what does acceleration tells you? Acceleration tells you that is your body increasing this speed or is it decreasing this speed? Alright? So these are the basic things, and now what is next? Equations of motion. Okay, equations of motion. You have learnt many equations of motion in class 9th, and probably you know the derivations also, that how these relations came into being. So this is the very first equation. V is equals to u plus at, or we say A is equals to V minus u by t. Okay, the second equation, again simple one, S is equals to ut plus half at squared. Okay, the third equation, V square minus u square is equals to 2as. These basic equations we have learnt in class 9, we have derived them, and we have solved some numerical problems also based on this. But now you are in class 11th, the things are not simple. There are two more equations. This might also you have learned if you are very much interested in solving numericals. Equation D is what? It is about the average speed. What is average speed? How do you find the average of two numbers? Just add them and divide by 2. Okay, so this is the average speed. V final velocity plus u initial velocity divided by 2. And average velocity is also defined as s by t. What is s? It is the total distance covered, and what is t? T is the total time taken. So this equation we are also going to use, and plus there is one more equation, a bit dangerous, not difficult, dangerous. Okay, Sn. What is it? Sn, and what it is? U plus a into bracket n minus half. So these 5 equations are the very, very basic equations, and they are always needed from the day you take the first lesson of physics in class 9 till the last day. If you are doing engineering, if you are doing your masters or even PhDs, these 5 equations are the very, very fundamental equations of physics. Okay, in the next lecture we will derive these 5 equations of motion, that how these equations came into existence. Clear? That's all for today.